VPNs provide an encrypted tunnel to allow two endpoints to communicate together over an untrusted network. There are a couple of VPN concepts beyond that we need to go through. First of all, let's talk about VPN IT service delivery. A VPN solution could be delivered to clients either as a hardware appliance or as a software appliance, whether that software appliance is on premises, perhaps as a virtual machine, or in the cloud. It doesn't have to be a virtual machine. Your software appliance could be a dedicated hardware server configured as a VPN device. However, hardware appliances that are designed specifically and only to serve VPN uses are usually the most secure, stable, and can handle the most simultaneous VPN connections. We then have to consider service level agreements, or SLAs. The SLA is a contractual document between a service provider and a service consumer. In this case, the service we're talking about is VPN connectivity. The SLA will detail things like guaranteed uptime for the VPN, guaranteed performance metrics, such as a guaranteed minimum number of bytes that are able to be transferred within a specific period of time between VPN endpoints. The SLA could apply to a VPN service that's being delivered to clients either on premises, on a private network, or in the cloud. There are a number of VPN components that must work together to provide an entire VPN solution. The first of which is the VPN client. Depending on the type of VPN that's being used, the VPN client could turn out to be actual VPN client software that's installed from a specific vendor, whether that vendor is Microsoft or Cisco or Juniper and so on. However, the VPN client could also be as simple as a web browser in the case of SSL VPNs, which we'll talk about. Another component is the network access server. This is sometimes called a radius server. The idea is we don't want the VPN device doing authentication when VPN clients attempt to connect to the VPN. Instead, we want the VPN device to forward authentication requests to a server elsewhere. And that's where the network access server or radius server component comes in. The term tunnel terminating device really stems from the fact that an encrypted VPN tunnel will exist between 2 points, such as a client and its VPN software and the VPN device over, for example, the internet at another location. However, after traffic gets to that other endpoint over the internet, it gets decrypted. And so we call those VPN devices tunnel terminating devices. You'll also hear the term VPN concentrator. The VPN concentrator is the device that allows multiple simultaneous connections from VPN clients. And hardware appliances are usually what we're talking about when we refer to a VPN concentrator. As we've mentioned, there are both hardware and software VPN solutions. And it really depends on the need and really the scale. So for larger scale enterprise VPN deployments, if we need more VPN client density, we're really probably looking at a hardware VPN concentrator type of solution. IPsec stands for IP security. It's a protocol that's used to authenticate and encrypt network traffic, but it does not have to be used with a VPN, although with some types of VPNs it is used. IPsec supports a couple of different modes where we can use authentication headers, or AH. The authentication header, like the name implies, is used to authenticate where the connection is coming from. But there's also the aspect of encapsulating security payload, or ESP. This is the part of IPsec that actually encrypts the data part of a packet and protects it from prying eyes. With IPsec tunnel mode, packet encapsulation and tunnel mode might be what we use if we configure a site-to-site VPN, for instance, to link two offices together over the internet. If we take a look at the structure of a packet prior to being encrypted with ESP, or encapsulating security payload with IPsec, it would look kind of like this. So we've got the Ethernet header, which contains the source and destination MAC addresses. We've then got the IP header, which contains, among other things, the source and destination IP addresses, Assuming it's a TCP type of transmission as a transport, then we'll see a TCP header with the source and destination ports, among other fields, and then we have the actual payload. So that would be the actual original IP packet prior to being protected with IPsec. The next thing we'll see here is the encrypted IP packet. And really, if you'll notice what's different is we've got something new after the IP header. That's the original IP header. We've got something called an ESP header, the Encapsulating Security Payload Header, which will contain, among other things, something called an SPI. The SPI is the Security Parameter Index. And this is an identification type of number that's used to identify the network traffic stream between the two endpoints. After the ESP header, we then have an encrypted TCP header and encrypted payload. So it's scrambled. We can't even tell which port number was used when we talk about using encapsulating security payload. So this is one way that IPsec can be used to protect network traffic.